Hi, um, it's me again. um, Today we're going to actually try to do a problem that I have not have that I didn't do before. So it's a number of enclaves. So we're given a m by n binary matrix grid where 0 represent a C cell and 1 represent a land cell. A move consists of walking from one land cell to another adjacent land cell or walking off the boundary of the grid. Return the number of land cells in grid for which we cannot walk off the boundary for grid in any number of moves. So what this means is so whenever we met a new question is to understand the cues, ask clarifying question, and ask question about the inputs. And before we even wrote the code, we talk about the solution, pseudocode, and time and space complexity. And then we actually code it and we test it. Okay, now let's understand the question. So we have a binary matrix. 0 means the sea, 1 means an island. A move consists of walking from one land cell to other adjacent land cell, where we can just walking off the boundary cells. Return the number of land cell in grid for which we cannot walk off the boundary of the grid in any number of moves. Okay. So in this example, we have 3 ones, no problem. In this example, since every cell is connected with land, so we would have 0. Okay. It looks like that we need to first count the number of ones that are actually adjacent to the boundary, and we can switch that to 0, switch all the adjacent to 0, and we just need to count the inner land. Okay, cool. So in order to switch all the ones that are adjacent to the bounds, I will do a DFS. We can do a DFS about the boundary and basically change all ones to zeros that are close to, that is near the bound. And after that, we do a linear scan of grid and count inner ones and return that count number. Okay, cool. So the time complexity would be OMN, where M is the number of rows and N is the number of columns. And the space complexity will also, in the worst case, it depends on how many times we call the recursion stack. In the worst case, it also will be OMN. So time M times N, space will also be M times N. Okay, great. Let's code it up. First, let's still take the rows and column number from our grid. And then we want to do DFS for 4 boundaries. So for the first boundary is if on left and right, so j equal to 0 and columns minus 1. So we just do if my grid I 0, the left boundary equals to 1, I can do my DFS, and if my equals to 1, I and columns minus 1. Then we will do the same for top and bottom boundaries. Zero, J. Okay, cool. So after this DFS for its 4 boundaries, what we can do is we just initiate a count number, and we want to return this count. Basically, we do a linear scan of the matrix, and if we encountered a 1, we increase the count. Let's fill this out. Plus plus. If we encountered a 1, we increase the count. Now let's go into this DFS. So the DFS is not going to return anything. All it does is to mark the ones to 0. So it has input and J. Let's take the rows and columns here. And the first thing is we need to check whether it's out of bounds. If my I is smaller than 0, or I is greater than equal than rows, or my grid I and j does not equal to 1, I will just return. Otherwise, I mark equal to 0, mark, and then I keep exploring. I call my DFS 4 times, right? I plus 1, 4 directions. Okay, cool. I think that's pretty much it. So for this one, yeah, let's try run the code. Great. Cool. The logic is pretty much the same with number of islands, except that for this question, we need to be careful of not counting the boundaries. But other than that, we build up, it's a searching matrix, we build up the framework for the search, and we write the logic for the helper DFS. While we do a linear scan of the grid, we just do, whenever we encountered an island, we traverse it and mark it. Great.